right, let's start. All right, let's start. That means you're quiet, correct? Thank you. A tent is supported by a guy rope tied to stake as shown in the diagram. What is the length of the rope? Okay, so you have a tent over here. Can everybody see the triangle that it's making? Yes, the triangle will be right over here, right? And you have the stake, and you're looking for the rope. All right, so which one is the rope? A, B, or C? C. See, this is what happens when you don't make the arrows. You don't know what you're looking for. So what am I looking for? C. How do you look for C? A squared plus? All right. So what's my A and what's my B? So 8 squared plus 6 squared. Go for it and tell me how much you got. We're working. What do we got? 10. Very good. And those would be 10 what? 10 feet. Thank you. 10 feet. All right, let's go to the next one. In the support and stake in problem 1, if the support and stake in problem 1 were 15 feet from the tent and 8-foot 10 pole were used, what would be the length of the guy rope? So now the measurements have changed, correct? Now, the stake is 15 feet away from it, so let's go ahead and make a triangle. That would be, this is the stake. That's 15 feet away from it. And an 8-foot 10 pole. So now my pole is not 6, is what? 8. I still got to figure out the rope. All right, so 90 degree where the L is. Arrow pointing away from it. What are you looking for? C. So which would be A squared plus B squared. What's my A and what's my B? 15 squared plus 8 squared. What do I got? 17? 17 what? 17 feet, most definitely. Stephanie's planning a right triangular garden. She marked 2 sides that measure 24 and 25. What is the length of side N? All right, you have your 90-degree angle. First thing you need to do is arrow pointing away from it. What do we got? What are we looking for? A or B. Very good. So I heard A. So how do you calculate for A? C squared minus B squared. Very good. What's C? Very good. It's what? The arrow always points to what you can see. So that would be 25 squared minus 24 squared. What do we got? 7. Very good. 7 what? Feet. All right. A builder needs to add diagonal braces to a wall. The wall is 16 by 12. You have it over here. What is the length of each brace? Can you see the triangle? Because this is the brace, right? All right, so 90-degree angle where the L is, arrow pointing away from it. What are you looking for? C. Very good. You're looking for C. How do you look for C? A squared plus B squared. So that would be 12 squared plus 16 squared. And you could have written it the other way around. It really doesn't matter because you're adding them, correct? What do we got, my babies? That would be 20. Very good. 20 what? 20 feet. Most definitely 20 feet. All right, the diagram at the right shows a post was broken. Do you see it broken? What was the original height of the post? All right, so talk to me about how I can do this. Okay, so I have that from here to here is 2 feet, from here to here is 18 inches. That's my first challenge because what happens over here? 2 feet, 18 inches. What do you notice about those measurements? They're different. They're different, so I cannot use them. Very good. I have to either change everything to feet or change everything to inches. Okay? So, since this is a pole, what would it make sense? To change it to feet or to change it to inches? This is a pole to feet. Thank you, because the inches is going to be huge, right? So I need to change those 18 inches to feet. So how many inches are in a foot? 12 inches. Very good. So if I say 18 minus 12, and how many feet is 6 inches? 1.5. This would be 1.5 because this is 1 foot, and that's half a foot. Very good. So this would be 1.5 feet. Say that again. 1.5 feet. So now I can do this. So I need the whole pole. So I know that from here to here is 2 feet, but I don't know how much is this. So what can I do now? 90-degree angle and arrow pointing away from me. I'm looking for C. Very good. I'm looking for C, and that would be A squared plus B squared. So that is 2 squared plus 1.5 square. What do I have, my babies? 2.5. There you go. Is that my answer? So this side over here is 2.5 feet. What is it asking me to do? How long was it before it broke, right? I got to add 2.5 and 2. Very good. Now I got to take that number and add it up. Very good. So that would be 4.5 feet. Good job. See, most of you, if this was an ABCD, stop at 2.5 because you're not going back to your question. Be careful. You saw it on the exit ticket how most of you did not finish. All right. The sets of number 3, 4, and 5 and 5, 12, 13 are examples of Pythagorean triplets. Use what you know about the Pythagorean theorem to explain why these numbers are called Pythagorean triplets. Okay, what is the first thing that you need to know about Pythagorean theorem? It only works for what? Right triangles. Very good. That have a right angle. Very good. So how can I prove that those are triplets? This has to be true on 90-degree triangles, on right triangles. What do you know about C? It's the longest one. Very good. So what is C on the first 3 numbers? On the first set of numbers? 5. And what is C on the second set of numbers? 13. So let's see if it works, and then we can prove that it does. So what is A? 3 squared plus 4 squared should be equal to 5 squared. What is 3 squared? What is 3 squared? 9. What is 4 squared? 16. What is 5 squared? What is 9 plus 16? Is 25 equal to 25? So there you go. We just proved that that's a right triangle. Let's do the next one. 5 squared plus 12 squared equals 13 squared. Let's see what 5 squared would be. 25, correct? What is 12 squared? 144. And what is 13 squared? 169. Now I got to add those two. And if it's equal to 169, I got it. This is a right triangle. So 144 plus 25. 169. So is it a right triangle? Most definitely, because 169 equals 169. So I just proved that both of them are right triangles. Yay? All right, let's go to the next one. The first thing that we need to do is scratch this one because we're not going to be able to see it. I don't know what that number was. All right, so we got to figure out if those are right triangles or not. If they're triplets or not, which means do they belong to a right triangle? So we got to do this right here. A squared plus B squared equals C squared. What's my C on the first set of numbers? 17. Thank you. So let's plug it in. 8 squared plus 15 squared should be equal to C squared. 17, I'm sorry. 17 squared. All right, let's see. 8 squared plus 15 squared. How much would that be? 8 squared plus 15 squared. 289. That has to be equal to 17 squared. If this is a right triangle. Is it equal? Yes, it is. So this would be a yes. All right, let's go to the next one. What's my C? 25. Notice that I only highlight my C. All right, so this is 15 squared plus 20 squared should be equal to 25 squared. So let's see if that's correct. 15 squared plus 20 squared. 625. Now if 25 squared equals that, is it a yes or is it a no? It's a yes. Oh, is that a yes? It sure is. So that's another yes. All right, let's do this one. What's my C on the third one? 11. So this would be 2 squared plus 9 squared equals 11 squared. Let's see. Let's do the math. 2 squared plus 9 squared. 85. And then what's 11 squared? All right, so are those two the same? So is this a right triangle? Nope. That would be a no. All right, let's do the last one. What's my C on the last one? 89. Very good. So this would be 39 squared plus 80 squared equals 89 squared. Let's do the math. 39 squared plus 80 squared. 7,929. 21. And then I got to do 89 square. We're not using the calculator, and that worries me. 79, 29, 21, I'm sorry. So is that a yes or a no? That's definitely a yes. All right, put that in your notebook. All right, let's go to the packet. I gotta get one for her and then put it on the with her name. So, um, get one from the back for her. Make sure it has batteries. Closet. Make sure it has batteries. Baby girl, I need you to write your name and your ID on an index card so that I can add you to my list and make you a notebook and all that good stuff. Don't lose the papers that you are um, that you're using today, because tomorrow, see, everybody has a binder. Tomorrow we'll make you one. So I need your name, make sure that I can read it, and your ID number, okay? And then give that to me. And your calculator, you give it to me because I need to make a little label for your name, okay? Thank you, baby. All right, are we good? Let's go. We're here, right? All right, are we good? All right, let's do. In order for entrances to be accessible to all, ramps are being put in place in two different buildings. One will be smaller than the other. However, both ramps must be proportional in a 3-to-1 ratio. Two measurements are provided below. What are the measurements of the other sides? Okay, so they're 3-to-1, right? What does a 3-to-1 ratio mean? You studied this last year in 7th grade. So now we're just remembering that and adding the Pythagorean theorem to it. What does a 3-to-1 ratio mean? Say that again. Yeah, it's a fraction, yes. But what does it mean? Say that again. One figure is definitely bigger than the other. How much bigger? Jamilet and Jonathan. One of them is bigger than the other. How much bigger is this one if the ratio is 3-to-1? You don't have a what? Can somebody get her one, please? Say that again. Is 3 times bigger. Very good. So this one is 3 times bigger. All right? This figure over here would be 3 times bigger. All right? So, I'm going to stop. Jamila, am I going to have to change you, baby? Then let's keep it together, please. All right. So if this is 3 times bigger, how can I figure out that side? Very good. You take that 3 and you multiply by 3 and you get that this is 9. Now can I figure this one out? Yes, I can. But I won't use ratios. What will I use? PT. Right? I will use PT. So what am I looking for over here? A or B. Very good, because this would be C. All right, so let's do A. So that would be C squared minus B squared. What is C? What is C? 23.4 square minus 9 square. So let's do that. How much is it? 21.6. Very good. So this side is 21.6. Now I need to figure out this side. So if I'm going from the big one to the small one, what do I need to do to those two numbers to figure out the small ones? Divide them by 3. Very good. Because if I go from the big one, from the small to the big, and I multiply by 3, if I'm going from the big to the small, I have to divide by 3. All right. So let's do 21.6 divided by 3. How much would that be? 7.2. Say that again. Yes, you got it. And then 23.4 divided by 3 would be 7.8. And there you go. I have all my measurements. There should be a packet over there. All right. All right, let's go to this one. The one at the bottom with the formula. The area of a circle A is 141 centimeters cubed. Find the length of chord XZ. So I'm looking for that. Use the given formulas to help you and round your answer to the nearest tenth. All right. Nearest tenth, what does that mean? Take a look at your cheat sheet and tell me I need to change that float to what? To 1 after the point, after the decimal, 1 decimal. Very good. So that means that I need to come to my mode and change that float to 1. Everybody needs to be doing that right now. Change your mode. Change your float to 1. All right, are we done? Sorry, my worker is locking off. All right. So let's go back to this. I'm going to stop. Leslie, come over here and change over here, please. We can't stop talking, baby. And I've told you. So obviously me telling you it's not doing anything. So I'm going to have to take it up a notch and change you. All right. So what is this from the circle? No, what? Yeah, it is a 90-degree angle. And you're looking for C, but you don't have the other two sides. That's the radius. Very good. So what we need to do is we need to use this formula right here to figure out the radius. Okay? Now what's the area? But what's the area? 141. That's the formula. You're absolutely right. The formula is pi r squared. But what's the area? 141 equals pi r squared. This is an equation. What can I do? Do you know the radius? No. So that will be your x, right? 141 equals pi x squared. Where can I go to solve this if it's an equation? Equation solver. Very good. So guess what? I'm not going to move pi x squared. I'm going to move what? 141. So let's go. Write what you haven't highlighted. Let's do it. All right. So let's go to Math Solver. And this is your pi key. Do you see it? Yes? So second, right here, it's in blue. Can everybody see it? It's in blue. It's right there. Can you see it? You're not talking to me, so I don't know if you can see it or not. Oh my God, Meg, you're getting on my nerves today. What's going on? X, and then this is how you put the square. And then minus 141. And then you hit enter, alpha, enter. And that's it. She will solve it for you. So what's your radius? Okay, but you need to round to the nearest tenth. See, she's not rounding. I don't know why. Maybe because it's on equation solver. So negative 6 point. No, 7. 7, right? Yay? Negative 6.7? Yes? All right, so now these two are negative 6.7. So now I can use my Pythagorean theorem. So to calculate for C, you got to do a squared plus b squared. What's a squared? Negative 6.7 squared plus negative 6.7 squared. You got to put it in parentheses though. Let me see if I don't put it in parentheses what happens. Yeah, you had to put it in parentheses. Yeah, you got to write it like this. You got to put it in parentheses. That negative 6.7 has to be inside parentheses. You ready to finish? Then let's go. If you don't put it in parentheses, it's going to give you error. Because it's a negative number. You got to put it inside parentheses. No, did you add it or did you subtract it? You make that mistake way too much. You add instead of subtract and subtract instead of add. That means you're doing it way too quick. No, it has to be outside the parentheses. All right, so what's my answer? 9.5. Very good. So x z equals 9.5. And I don't have any, oh yeah, centimeters. There they are, centimeters. So this is my answer. All right, go ahead and put that in your notebook.